Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 4 of lesson number 9, Force and Laws of Motion. So now the name of the lesson is Force and Laws of Motion, and if you remember we had a small part discussing about force, like what are the different events that occurs and what force can do, right? Like we discussed on that force can change the direction, force can change the speed, if you all remember, right? So we discussed a small part on force, and then we started with the, like, there are three different laws of motion. So we have like almost completed with the first law, that is also known as law of inertia. So now we are just left with one short part, that is inertia and mass, to discuss. Okay, and then we will be proceeding with the second law of motion. But like as I show you all the slides one by one before I end up with the part, you know that there are so many examples, like 5 to 6 examples just relating to the second law of motion, making you like more aware about the concepts, right? So I just want each one of you to please go through like whatever notes you have taken in your book, and then we will proceed with the actual part for the lesson. Okay? I hope every one of you have started revising it. So we have started the lesson by discussing about force, and we have the like definition for it, that force is a push or a pull on an object that is going to produce acceleration in the body, right? And the SI unit of force is Newton. Now SI unit plays a very important role, so make sure you know it. And then we started that force can do three things on a body. It can change the shape of a body, it can change the direction of the motion of a body, and it can even change the shape of a body. Okay? Now I hope you are not only focusing on the written content but also the images that they have shown, because those are the real life examples which are actually letting us know where exactly we are applying force, right? So please go through that as well. After this, we discussed on like effect of force, like it can be understood by the following points. So we have the 4 points which have been given over here. I want you all to please go through this part as well. After this, we discussed on the two types of force that we have. One is balanced force and the other one is unbalanced force, right? So balanced force is where like two forces act, like two forces which are acting, they are going to be of acting on the body will be of equal size, right? And it's going to be the opposite of unbalanced force. Like you can get a differentiation table over here where you will be asked to write differentiation between balanced and unbalanced force. Okay, so you have to be prepared with that as well. Then we discussed on unbalanced force as well. I want you all to go through this as well, everyone. I hope every one of you are going through it, and make sure you go through the exercise as well. Sorry, the figure that has been given as well, the example, not the exercise. After this, we discussed on the first law of motion. So I want you all to please go through it as well. I hope you all are going through this slide as well, where we have the first law of motion which has been given. After this, here we have more information on the first law. So I want you all to please go through it as well, everyone. You have to understand like how exactly the inclined plane is like helping like the movement of the marble. Okay, that is what is important over here. I hope every one of you are going through the slide. Then we discussed on this activities 9.1 as well. So I just want you all to please go through it quickly as well. After this, we discussed on activity 9.2. So I want each one of you to please go through it as well. After this activity 9.2, we had like activity 9.3 as well, which I want you all to please do it if possible, and then we'll study the next part. After this, like now, we need to discuss on inertia and mass. Though we had discussed it earlier, see, inertia is the natural tendency of an object to resist a change in its state of motion. What is inertia? It's the natural tendency of an object to resist change in its state of motion or of rest. Okay, then they have given that the mass of an object is a measure of its inertia. What is the mass of an object? The mass of an object is measure of its inertia, and a force that is just enough to cause a small cart to pick up a large velocity will produce a negligible change in the motion of a train. because of train's large inertia. So whatever force that we have, that is because of like large velocity which is acting on it, and that large velocity is going to produce a negligible change. It means it is not going to produce any change in the motion of the train, because the, like you can say, because the inertia of the train was more as compared to this. I hope everyone is going through the slide as well. Now the next thing that we need to discuss is the second law of motion. So I hope every one of you have understood about the first law, which is also known as law of inertia, right? Now the second thing that we have is, see, we are going to discuss the second law now. See, the first law of motion indicates that when an unbalanced external force acts on an object, like the force is unbalanced and it is external as well. So when an unbalanced external force is going to act on an object, its velocity will change and the object will get accelerated because the velocity is changing, you will find out that it is going to have an acceleration, it is going to move. So we would like to study how the acceleration of an object is depending on the force applied to it, and how can we measure a force. What are we going to study in the second law is how acceleration of an object is depending on the force, because if you are applying more force, acceleration will be more. If you apply less force, acceleration will be less, right? So we are going to study how acceleration and force are interrelated, and how can we measure a force. We are going to study both of it. Okay, so let us recount some observations from our everyday life, because all the three laws that you're going to study, you can relate them to the real life examples as well. So we are going to relate it to some observations from our everyday life itself, so that you understand the second law of motion properly. Okay, now just imagine like you're playing a table tennis game. So during the game of table tennis, if the ball hits a player, it does not hurt him, right? Because we are playing table tennis, and if the ball of the table tennis hits the player, the ball is not going to hurt him. On the other hand, when a fast moving cricket ball hits a spectator, it may hurt him, right? There is like, tennis ball is not going to hurt the player, but the fast moving cricket ball is going to hit the spectator, right? This is one of the example we can say, where like we have ball in both the cases. It's just that the table tennis ball is not hurting the player, whereas a fast moving cricket ball is going, like it's very obvious that it's going to hit the spectator, right? And you might have seen that in like matches and all, IPL matches and all, so you might be aware of it as well. So on the other hand, when a fast moving cricket ball hits a spectator, it hurts him. So a next example that we have is, a truck at rest does not require any attention when parked along a roadside, right? If the truck is at rest, we know that we have parked it properly, right? We don't have to like pay attention to it, whether it is like going to move forward or accident can happen, nothing, right? But if the truck is moving even at a speed as low as 5 meter per second, it may kill a person standing in its path, right? The speed is so less, but still the truck, because it's moving, it can kill a person as well, right? So a small mass such as a bullet may kill a person when fired from a gun, right? So all this observation suggests us the impact which has been produced by the object, it depends upon their mass and velocity. Starting from the example of table tennis till the bullet and the gun, they all are example, you can say, like you can say that these observations are going to have impact, and that impact has been produced by object. Okay, all the impact you can say, it is going to depend on mass and velocity. What does it depends on? Mass and velocity. So similarly, if an object is to be accelerated, we know that a greater force is required to give a greater velocity, right? If you want the velocity to be much like greater, you will have to like accelerate greater force as well. In other words, we can say that there appears to exist some quantity of importance that combines the object's mass and its velocity. What can we say? There is like some quantity that plays a very important role, because that is what when combines, that is what combines the mass of the object's mass and its velocity. Okay, so one such property is called momentum, and that was again introduced by Sir Isaac Newton. The T is for the next point, the momentum. Okay, so ignore that. So over here, whatever examples that we went through is letting us know that greater force is required for giving a greater velocity, or in short we can say that there are some quantity of importance that is going to combine object's mass and its velocity. And one such property that we have, we know it we know it as momentum, and momentum was introduced by Newton. Who introduced momentum? Newton. Okay, so momentum, which is denoted by small p, Momentum of an object is defined as product of its mass m and velocity v. What it is defined as? Product of mass and velocity, that is p, which we know it as momentum, that will be equal to product of means multiplication, that will be equal to mass into velocity. So p is equal to mv. So that is p is equal to mv is the formula for momentum. So in the second law of motion, we are mostly going to discuss on the momentum part. Okay, and remember one thing, that momentum has both direction and magnitude. What does it have? Momentum has both direction and magnitude. So now I want you all to write this part in your book as well and try to understand it from your end as well. Okay? I hope every one of you are going through it. I hope every one of you are writing about momentum in your book. After this, see, we have like about more information about momentum. So its direction is the same as that of velocity v. So momentum's direction will be same as that too of the velocity v, and the SI unit of momentum is kilogram per meter, kilogram meter per second, kg meter, kg for kilogram, m for meter, per second is s minus 1. Okay, now since the application of an unbalanced force brings a change in the velocity of the object, it is therefore clear that a force also produces a change of momentum. What that statement means is, like we already discussed about the unbalanced force acting on it, right? So because whenever like there is going to be an application of an unbalanced force, that brings a change in the velocity of the object, and therefore it is very clear that force also produces a change of momentum, right? So let us consider a situation in which a car with a dead battery is to be pushed along a straight road to give it a speed of 1 meter per second, which is sufficient to start its engine. So what is the situation where a car is like with a dead battery, and like that, because it is with a dead battery, you cannot drive that car, right? So we need to push that along a straight road to give it a speed of 1 meter per second, and that will be sufficient enough, and the engine will start. Okay, so if one or two person gives a sudden push, it hardly starts, but a continuous push over some time results in gradual acceleration of the car to the speed. What happens? A continuous push over some time will result in gradual acceleration of the car to the speed. It means that change of momentum of the car is not only determined by magnitude but also by the time during which the force is exerted. So only the magnitude is not important. The time during which the force is like exerted, or time period for which the force is exerted, also plays a very important role. Okay, so it may then be concluded that force the force necessary to change the momentum of an object depends on the time rate at which the momentum is changed. On what it will depend on? It will depend upon the time rate at which the momentum is been changed. And the second law of motion states that rate of change of momentum of an object is proportional to applied unbalanced force in the direction of force. What does the second law state? Rate of change of momentum is directly proportional to applied unbalanced force in the direction of the force. Okay, so now I want you all to write so many points which are important over here on the screen, and I want you all to please take a note of it in your book. I hope every one of you are even taking note of it. After this, now in the next class, we will be discussing about the mathematical formulation of the second law, that is P is equal to mv, right? That is mass into velocity. So we'll be like deriving that formula in the next class, where I will be teaching you how exactly we are getting that formula of momentum. But whatever we discussed for the second law of motion, what does it states? Rate of change of momentum is proportional to applied unbalanced force in the direction of force. What did I said? Rate of change of momentum is proportional to applied unbalanced force in the direction of force. Okay. So we will discuss this mathematical formulation of the second law of motion in detail. Then we will discuss on this example, like there are 6 to 7 examples for the second law of motion that we will be discussing on. Okay, so I'm going to show you all the examples. But we are not going to discuss it now. We will discuss it in detail after we complete discussing everything. Then we will discuss on third law of motion in detail. Okay, and after that again we have many activities and examples to discuss. So we'll be doing that as well. After discussing the third law of motion, we have conservation of momentum to discuss, which we will be discussing on. And then we have again like activities and examples given in bulk. And after that we have the summary discussion of the whole lesson, force and laws of motion, of what exactly we discussed so far. So now I just want each one of you to please go through the exercise question as well, because we will be doing that as well at the end, right? So please go through it. I hope every one of you are going through the question. So this is how we will be ending up with the lesson force and laws of motion. And I hope whatever we discussed today for this part, like in this part for the lesson force and laws of motion, every one of you are clear with it, because the rest of the part for the lesson I will be starting that in the next part itself, where we will start with the second law of motion. We already discussed on what does it states, right? We are left with like how can we mathematically come up with or express momentum, that is p is equal to, that is p is momentum is equal to mass into velocity, right? So we'll be having that mathematical derivation in the next part. So make sure you revise everything that we had discussed so far. Okay, so I'll end this part over here. Thank you everyone.